This next video is where things start to really get weird when we use infinity. So the problem seems innocent enough. We're asked to find the area under the curve y equals x. So all this stuff over here in red is going to be positive. All this stuff over here in blue is going to be negative. And you might think just by looking at it, okay, whatever positive area I have over here is going to get balanced out by whatever negative area I have over there. Right? So this should just be whatever that is minus that. Well, they're equal. So shouldn't the answer just be 0? That's kind of what our intuition tells us. So if I was finding the integral from negative 10 to 10, yeah, that would be 0. If I was finding the integral from negative 20 to 20, yep, that would be 0. Okay, any number I could pick, yes, that integral would be 0. But they want the entire curve, so all the way from negative infinity to positive infinity. So let's take a second and see if we can figure out what the actual answer should be here. So this is essentially the integral from negative infinity to infinity of x dx. Okay, because I've got both limits being infinite, I need to split it up into 2. So I'm going to let a approach negative infinity and go from a to 0. And then I'm going to let b approach positive infinity and go from 0 to b. Again, there's nothing magic about 0, it just tends to be easy to plug into most functions, so it's generally where I split things. Okay, so this is going to be the limit as a approaches negative infinity of, well, the integral of x is just x squared over 2. Okay, same thing's going to happen here. So now let's plug in those limits of integration. I've got 0 squared over 2 minus a squared over 2. And then, in my second limit, I've got b squared over 2 minus 0 squared over 2. Now just to clean these guys up, 0 squared over 2 is just 0, so that goes away. Okay, same with this guy over here. So I've basically got to my answer now, and it really looks like these guys are still going to cancel out. But let's go back to what the definition says. If we're going to have that integral converge to some answer, then every single limit we do has to converge. So I can't just pretend that I'm combining those limits. I need to do the limits one at a time to get my answer. Okay, so let's start with this first limit. The limit as a approaches negative infinity of this guy. So if I use direct substitution here, and I plug in a equals negative infinity, well, if I square that, I will get positive infinity. So this is negative infinity over 2. So does that converge? No. At this point, I don't even need to bother with the second limit. I know that one of my limits does not converge, so I know the answer to the problem is the integral diverges. So again, this goes completely against our intuition. If I went from like negative 5 to 5, the integral would be 0. If I went from like negative 17 to 17, the integral would be 0. But our intuition generally does not work when we try to extend things to infinity. We really have to follow the definition. So the correct answer here, even though it looks like things should cancel out, is just the integral diverges. Right? It's not appropriate to pretend we can talk about finding that total area under that curve, because it doesn't really cancel out when you have two infinite numbers. So the answer here, once again, is that it diverges, because we would actually find that both limits diverge. But all we needed is for one limit to not converge. So that means the integral diverges here.